Alright, so in this video we're going to look at truth tables. Alright, so here we're going to say let P and Q be two logical statements. The statements P and this symbol here, that's read P and Q, is true if and only if P and Q both are true. So in other words, for this to be true, both statements have to be true. If one's false or if both of them's false, then the whole statement would be false. And you see the symbol that we use here for and. Some other symbols would look like this, or we could just write out the word and. And then here the statement P or Q, that's how it's read, P or Q is true if and only if at least one of P and Q is true. So that means if just one of them is true, or if both of them are true, then that makes the whole statement true. The only way it would be false is if both of them are false. And another way that we can write this symbol here, or, would be with this symbol, or we could write out the word or. And then here we denote P implies Q by P and then this symbol Q, which is false if and only if P is true and Q is false. So that's the only time that this statement's false, is if this one is true and this one is false. Any other time the statement's true. And then we denote P as equivalent to Q by P and then this symbol Q, which is true if and only if P and Q have the same truth value. So if P and Q are both true, then it would be true, or if P and Q are both false, then it would be true. They have to have the same truth value. And then exclusive or is denoted by P and then this symbol Q, which is true if and only if P and Q have opposite truth values. So their truth values would have to be opposite in order for it to be true. If the truth values are the same, then it would be false. And then instead of P is not true, we would write this symbol here, P is true. This is the negation symbol. It means not P. All right. Now let's look at some common negations. All right, so here we have not P and Q is equivalent to not P or not Q. And then not P or Q is equivalent to not P and not Q. And right here I messed up a little bit. This should be a capital P instead of a lowercase p. And then the third one, not P implies Q, is equivalent to P and not Q. And the first two properties here are called De Morgan's laws. Okay, and then in a minute when we're going to do some truth tables for these properties up here, we'll do a truth table to prove this one, this number 3. Okay, all right, so let's look at the truth tables. So the first truth table I'm going to do is P and Q. All right, so remember P and Q, that's only true when both of them are true. So you can see here the first one, P is true and Q is true. Since they're both true, that makes this first one true. So I'll put a 1 there. And by the way, the 1 is going to represent true, 0 represents false. Another way that you might see it is to represent true, you may see a capital T. To represent false, you might see a capital F. All right, so now this one, P is true and Q is false. So since they're both not true, that makes P and Q false, so we would put a 0 there. And then here P is false, Q is true. So since they're both not true, then we would put a false. And then here both of them are false, so that makes P and Q false. Alright, so now let's look at the truth table for P or Q. So remember, for P or Q, at least one of them has to be true in order for it to be true. So one of them could be true or both of them could be true. Alright, so the first one you see P is true and Q is true. Since they're both true, that makes P or Q true. And then here we have P is true, Q is false. Well, at least one of them's true, so that makes P or Q true. And then here P is false, Q is true. At least one of them's true, so that makes it true. And then here P is false, Q is false. Since they're both false, that makes P or Q false. Alright, so now let's take a look at this. P implies Q. So remember, P implies Q is false when P is true and Q is false. Okay, that's when the first one is true and the second one is false. That's the only time it's false. So here, well, let's just go down here. See where P is true and Q is false? That makes this false. So we put a 0 there. Alright, now let's look at this one. P is true, Q is true, so that's true. Here P is false, Q is true, so that's true. And then here P is false and Q is false, so that makes it true. Remember, the only time it's false is when P is true and Q is false. Any other time it's true. Alright, now let's look at this. P is equivalent to Q. Now remember, this one said that this statement is true if they have the same truth value. So let's look at this. Here we have P is true, Q is true. They have the same truth value, so that makes it true. Here P is false. Here P is true, Q is false. They have different truth values, so that means it's false. And then here P is false, Q is true. They have different truth values, so this is false. And then here P is false, Q is false. They have the same truth value, so that makes it true. Alright, now let's look at exclusive OR. Now remember what exclusive OR said, that in order for this statement to be true, they have opposite truth values. Okay? Alright, so let's look at this. P is true, Q is true. They have the same truth value, so that means it's false. Here, P is true, Q is false. They have opposite truth values, so that makes it true. And then here, P is false, Q is true. They have opposite truth values, so that makes it true. And then here, P is false, Q is false. They have the same truth value, so that makes it false. Alright, and then as I promised, here's the proof for part 3 for my from those negations, the proof of part 3. And let's just go back and see what it said. It said, not P implies Q is equivalent to P and not Q. So we have to show that this statement and this statement have the same truth value. Alright, so let's look at this. So we need to show that this column and this column are going to have the same truth values. Alright, so before we do that, see, we have to do the negation of P implies Q. So first we need to get P implies Q. We need to get the truth values here. And then for this one, well, P and not Q, well, we have the values of P right here. And for not Q, well, we need that column. So that's going to be not Q. And one thing that I didn't mention, this 1 1 1 0 0 1 0 0, you noticed them in the other tables. These will be given to you. If they're not, you'll have to come up with them. It's just every possibility there is with two statements. You know, you can have true true, true false, false true, or false false. Okay, but typically these are going to be given to you. Alright, so first let's go ahead and get this column here, P implies Q. So you remember P implies Q is false only when P is true and Q is false. So this right here would be false. because P is true and Q is false. And any other time, it's true. So this would be true, this would be true, and this would be true. Okay? Now, let's look at not Q. Let's go ahead and fill this column out. So not Q, the negation, so here if Q is true, then not Q would be false. Here Q is false, so not Q would be true. Here Q is true, so not Q would be false. And here Q is false, so not Q would be true. The not Q, that or not P or not R, whatever letter it is, in this case not Q, is just the opposite truth value of what that letter is. Alright, now let's work on these columns here, and we should get the same thing. Alright, so we need not P implies Q. Well, here we have P implies Q. So not P implies Q, well, here it's true, so here it would be false. Here it's false, so we would have true. Here it's true, so that would be false. Here it's true, so that would be false. Okay? Now, this column here should match this column. Let's see what happens. So we have P and not Q. So we're looking at this column and this column, and we're doing and. So the only way that this is true is if both of them are true. Alright, well here we have true, false, so that's false. Here we have true, true, so that's true. Here we have false, false, they're not both true, so that means it's false. And here we have P is false, not Q is true, so that would make it false. And you can see that these columns here, they have the same truth values. Alright, now let's look at some examples involving several of them. Alright, so let's look at this example. We want to do P and Q implies not Q. Alright, so this part here that's in parentheses, we're going to treat that as one thing. Okay, that's going to be treated as one thing. And you notice here I have a column for that. So what we need to do is we need to fill out the column for P and Q, then we need to fill out a column for not Q, and then we can do the entire thing. Alright, so here we have P and Q. Now remember, in order for this to be true, both of them have to be true. So you can see we have true, true, so that would be true. Here we have true, false, so that would be false. Here we have false, true, so that would be false. And then here we have false, false, so that would be false. Alright, now not Q. Remember, not Q is just going to be the opposite truth values of these, of Q. So this is true, so this would be false. Here this is false, so that's true. This is true, so that would be false. This is false, so this would be true. Alright, so now we have these two columns. Now you see we can do P and Q implies not Q. So it's this implies this column. So P and Q implies not Q. So remember, implies, it's false when the first one is true and this second one is false. Alright, so let's see. See how this is true and this one's false? So that means it's false. And then here, now remember, any other time implies it's true. So see, this is false, true, so that would be true. False, false, so that would be true. And false, true, that would be true. And so this would be our answer. Alright, let's look at another example. Alright, so here we have P or Q and not R. Okay, P or Q and not R. So I have my three statements, P, Q, and R. And these are all the different possibilities that we could have. Okay? Like I said, this would probably be given to you. Alright, so let's go ahead and get this one done. So you can see here how I have the different columns because I need P or Q. That's this column. And then I need not R, which is this column. And then I can put them together. Alright, so remember, P or Q. At least one of them has to be true. So either one of them could be true or both of them could be true in order for this to be true. So I have true, true. See, I'm doing P or Q, so I'm looking at these two columns. So I have true, true. That would be true. Here I have true, true. That's true. True, false. Well, at least one of them's true, so that's true. True, false. So that's true. False, true. That's true. False, true. That would be true. Here both of them are false, so that would make it false. And here both of them are false, so that would make it false. Alright, so I've got that column done. Now let's do the column for not R. So remember, not R, that's just going to have the opposite truth value of R. Alright, so here would be false, true, false, true, false, true, false, and then see here's false, so that would be true. Alright, now let's put them together. I have this and this. So this is true only when both of them are true. Okay, so let's look. I have true, false, so that's going to be false. I have true, true, so that's going to be true. I have true, false, so that's false. I have true, true, so that's true. True, false, so that's false. True, true, so that's true. False, false, so that's false. And then false, true, that's false. Alright, now let's look at one last example. I have P implies Q or not Q is equivalent to R. Alright, so you can see here the different columns I have. I need to know what P implies Q is, so there's that column. And then I need not Q is equivalent to R. So in order to do this, I need to know what not Q is. So I have a column for not Q. And then I have not Q is equivalent to R, which is this one. And then once I get all of these, I can put it together by using this column and this column. Alright, so P implies Q. Okay, that is false when the first one is true and the second one is false. Alright, so I have true, true, so that's true. True, true, that's true. True, false. See, the first one's true, the second one's false, so that's false. The first one's true, the second one's false, so that's false. And then I have false, true, so that's true. False, true, that's true. False, false, that's true. And false, false, that's true. Alright, now let's look at the column not Q. Alright, so remember, not Q is going to have the opposite truth value of Q. Alright, so here I have true, so that's going to be false. That's true, so that's going to be false. That's false, so that's true. That's false, so it's true. That's true, so it's false. True, so that's false. False, so that's true. And false, so that's true. Alright, now we can do this not Q is equivalent to R. Okay, so for that, I've got to look at this column and this column. Okay, now remember, equivalent, that means in order for it to be true, they have to have the same truth value. Okay, the same truth value. So let's look at it. True, false. They're opposite, so that's false. False, false, so that's true. They have the same truth value. True, true, so that's true. False, true, so that's false. True, false, so that's false. False, false. Okay, so remember I'm looking at this column and this column. So false, false, they have the same truth value, so that's true. And then I have true, true, so the same truth value, so that's true. And then false, true, those are opposite truth values, so it's false. All right, now we can look at this column here. So for this one, I'm doing this or this. So that's this column and this column. Okay? And they're connected with or. So remember, or, at least one of them has to be true. So only one of them has to be true, or they both can be true. All right, so let's look at that. All right, true, false. Well, at least one of them's true, so that's true. True, true, so that's true. False, true, so that's true. False, false. Well, they're both false, so that makes the whole thing false. And then true, false, that's true. Only one of them has to be true, one or both. True, true, so that's true. True, true, so that's true. True, false, so that's true. And that would be your answer. Alright, so hopefully this video's helped. I've got some more videos. You can watch them if you like them. Alrighty, thanks.